Hello everyone, welcome to our statistics channel Quality Statistics. Today we are going to discuss relative measures of dispersion. A relative measure of dispersion is defined as an absolute measure of dispersion expressed as a percentage of a measure of central tendency. Thus, a relative measure of dispersion equals an absolute measure of dispersion by a measure of central tendency into 100. Relative measures of dispersion are used in two situations. Number one, relative measures of dispersion are free from the units of measurement. They are pure numbers and they can be easily used for the purpose of comparison. Number two, even if the two sets of observations are expressed in the same units, the absolute measures of dispersion gives us misleading information when their central values vary very much. To compare the variability of the two sets whose central values vary widely, we should use the relative measures of dispersion. Now, types of relative measures of dispersion are as follows. Number one, coefficient of range CR, coefficient of mean deviation, coefficient of quartile deviation and coefficient of variation. Now, formula of coefficient of range CR equals to HCB, that is the highest class boundary, minus LCB, lowest class boundary, by highest class boundary plus lowest class boundary. Number two, coefficient of mean deviation, the formula is CMD equals to mean deviation by median or mean into 100. Number three, coefficient of quartile deviation is CQD equals to quartile deviation by median into 100, and coefficient of variation CV equals to SD by mean into 100. All the relative measures are expressed in percentage term. Now, special focus on the concept of coefficient of variation. If we get the following words, then coefficient of variation is used. Number one, stability. Number two, consistency. Number three, variability. Number four, comparability. Now we present a problem on coefficient of variation. The problem is given as the mean life in days and standard deviation for two types of electric bulbs are given below. Type 1, mean life in days 310, standard deviation in days 9. Type 2, 260, mean life in days and SD in days 14. Compare the relative variability of life of the two types of bulbs. Let the mean and SD of type 1 electric bulbs be denoted by x1 bar and sigma 1, and that of type 2 electric bulbs be denoted by x2 bar and sigma 2. Given x1 bar equals to 310, sigma 1 equals to 9, x2 bar equals to 260, sigma 2 equals to 14. Now, to measure CV, we use SD by mean into 100, that is sigma 1 by x1 bar into 100, that is 9 by 310 into 100, that is equal to 2.90%, and CV2 sigma 2 by x2 bar into 100, that is 14 by 260 into 100, that is 5.38%. Type 2 bulbs has more variability than type 1 bulb. This is the solution of this type of problem. To test consistency variability, we use CV, that is coefficient of variation. This is all about today. Please keep watching our channel for new videos and new updates. Thank you all for watching this video.